Here we want to solve this integral, which is the integral of x cubed minus 7x squared plus 10x plus 1 over x squared minus 7x plus 10 dx. Notice this is a rational function, so we're going to use this note in here. Notice here the numerator degree is larger than the dominator degree. The numerator degree is 3, and then the dominator degree is 2. Therefore, we're going to use the first point in here. We're going to try to use long division, and then we're going to use the method of partial fraction on the remainder. So first, let's use the long division. Now, x cubed divided by x squared is x. So we're going to have x, and then I'm going to multiply this x here. So we're going to have x cubed, then minus 7x squared plus 10x. Now we'll subtract. Notice these will be 0, and this term also will be 0, as well as this term. What's left off is just 1. Therefore, the integrand, which is x cubed minus 7x squared plus 10x plus 1 over x squared minus 7x plus 10 equal to the answer, which is x, and then plus the remainder, which is 1, over the denominator, which is x squared minus 7x plus 10. Therefore, the integral of this side is going to be the integral of this side. Now, after the long division, we're going to use the method of partial fraction on the remainder, which is in here. So this integral is going to be the integral of x dx, and then plus the integral of 1 over x squared minus 7x plus 10 dx. First, I'm going to try to complete the square. Notice here we cannot complete the square since 7 is not a multiple of 2. Therefore, I'm going to try to factor this polynomial in here. So I want to find two numbers that when I multiply them, it can result in 10, and then when I add them, it can result in minus 7. These two numbers are minus 2 and minus 5. When I multiply them, it's going to be 10. Then when I add them, it's going to be result in minus 7. Therefore, we have the integral of x dx, and then this integral is going to be equal to 1, and then x minus 2, and then x minus 5 dx. Now, to solve this integral here, we're going to use partial fraction. Note in here we have two distinct linear functions, so we're going to use this point in here. Therefore, the fraction going to be in form of this. However, we already found the antiderivative of this using the partial fraction method. Review older videos. So the antiderivative of x going to be equal to x squared over 2, and then the antiderivative of the second integral going to be equal to minus 1 over 3 natural log of the absolute value of x minus 2 plus 1 over 3 natural log of the absolute value of x minus 5, and plus a constant c. And that should be the antiderivative of the given integral.